Hey everyone, I'm Connor and I'm going to be working out a problem from exam 2, number 1 for instructor Hamid's Statistics 2 3610 class. So yeah, I've written the problem out here. It's find the mean, median, standard deviation, variance, first and third quartiles, interquartile range, 60th percentile, and outliers in this given database. So we're going to start off with doing the mean. The mean is pretty easy. You all probably know how to do it. You just add all the values together. So 2, 6, 8, 9, 10. And you're going to divide it by the sample size, which in this case is 10. So you're going to, once you do all of that, you're going to get that the mean is 10.4. So make sure that you get this value because we're going to be using this a little bit later. So the median, Hamid teaches this a little bit different way, and he actually does it more accurately than some of your other math classes have done before. So he uses an interesting formula, and it's n plus 1 times whatever percent you're looking for. For the median, it'll be 50%, so 0.5. And that'll give you a number that we're going to use. So n in this case is 10, but plus 1 is 11, times 0.5 is 5.5. So we're going to be using this. So this first 5 is the 5th number in the data set, which in this case would be 1, 2, 3, 4, 5. So it'd be number 10. We're also going to be using the next number, so number 11. Then this number is the percent that we're going to be multiplying it by. So for this one, it'll be 50%. And for this one, it'll also be 50%. So once you do that, you'll get that the median is about 10.5. This might seem a little bit confusing, but we're going to be using this method later for percentiles and different number quartiles. So if you don't get it right now, just stay with me and it'll be easier. The next thing that we're going to calculate is, let me circle that. The next thing that we're going to calculate is the standard deviation. So you're going to have a formula on your formula sheet to be able to calculate this, but it's a little difficult to explain, so I'm going to do that. I'm just going to write out the formula. So the formula is the square root of the summation of x initial minus x bar squared all over n minus 1. So x initial equals the data point from up here. So we're going to be doing this multiple times. So x initial for the first one will be 2, the next one will be 6, the third one will be 8, and so on. X bar equals the mean, which we've already calculated to be 10.4 earlier, so that's going to be important. And n equals the number of data points, but minus 1. So n is 10, but this thing under here is going to be 9. So we're doing this for every data point. So I'm just going to show you an example, the first couple examples. So it'll be the square root of 2 minus, this is from the data, from minus the mean, and then you square it all over 9. And now we're going to add 6 minus the mean all over 9. And then we're going to add 8 minus the mean squared all over 9. And we're going to keep doing this until we get to the last one, which will be 19 minus the mean. Squared. So because the values are squared, they're always going to be positive, so you won't have any problems underneath this radical. So for the final answer for the standard deviation, you're going to be getting about 4.64, depending on how you round. Yeah, we've already done 3, so the variance is probably the easiest one to calculate once you've done all of this. It's just the standard deviation squared. So it's 4.64 squared, which equals about 21.6. So that's just something that you have to be able to know how to do. So now we're going to do the first quartile using this method that we used to calculate the median earlier. So the first quartile is the same thing as kind of asking which number is in the 25% range. So I'm just going to write 25%. So doing what we did earlier, you have n plus 1, so 11 times 0.25, which will give you 2.75. So this means that we look at the second number in data, and this means that this is one of the percents we're going to be using. So the second number is 6, so we're going to have 6 times 1 minus the percent, which we got here. Earlier it was 50, so they were both going to be 50, so it didn't make a difference. Plus 8, because that's the third number, times the percent equals the first quartile range. So it'll be 6 times 1 minus 0.75 is 0.25, plus 8 times 0.75, and we're going to get 7.5 as the first quartile number. We're going to do the same thing to find the third quartile. So 11 times 0.75, because third quartile is like the 75% value. And with that, you're going to get 8.25. So again, eighth number, and then 0.25 is the percent. So we go to the eighth number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 8 is, so 13 times 1 minus p plus 14 times p equals 13 times 0.75 plus 14 times 0.25, all of that to give you 13.25. So we've gotten the first quartile and the third quartile. So the interquartile range is just going to be pretty easy. It's just going to be the third quartile value we got for the third minus the value we got for the first quartile. So we're going to get 13.25 minus 7.5 equals 5.75 for the IQR. And we're going to be using this to find outliers. But now what we're going to be doing is getting the 60th percentile. And that's going to follow the same method that we used to get the quartiles. So once again, 11 times, and the percent in this case is going to be 0.6 because 60 equals 0.6. And with that, you're going to get about you're going to get 6.6. So we're going to go back to the data, 1, 2, 3, 4, 5, 6. And 11 is the sixth one, so 11, sixth number, percent. So 11 times 1 minus the percent plus 12 times the percent, which will equal 11 times 0.4 minus 12 times 0.6, and that's going to be 11.6 for the 60th percentile. We're doing great. Now all we have left to do is calculate the outliers. So normally in a lot of your engineering classes, how you're going to calculate the outliers is the interquartile range times 1.5. But because those can still be statistically significant, we're going to do interquartile range times 3. Yeah. So what you're going to look for is the two bounds that data should fall in, and if data doesn't fall in these bounds, then it's going to be an outlier and not good. So what you do is, for the lower bound, you do the first quartile minus interquartile range times 3. So 7.5 minus the interquartile range times 3, and you're going to get negative 9.75. And that's for lower bounds. For the upper bounds, you're going to get the third quartile. I'm just going to write first. You're going to get the third quartile plus the interquartile range times 3, which we got the third quartile earlier. It's 13.25 plus interquartile range times 3 to get 30.5. So we have the lower bounds being 9.75 and the upper bounds being 30.5. So we look at our data and we see that all of these points lie within this range. So because of that, we see that there are no outliers in this data. Yeah, I think that's everything. I think we've answered the question completely, and I'm glad to have been able to get the chance to help you guys out. So see ya.